Hello everyone and welcome back to our channel Quaint Cosmos. Recently, a fascinating discovery was made by an international team and published their results in the journal Physical Review Letters in April 2025. That means just the last month, because this is the month of May. The last month this discovery was made. What was the discovery? They created something new, and that creation is a creation of Hydrogen-6 isotope. Why it is so interesting? Because here the ratio of neutron to proton is 5:1, because in hydrogen-6 isotope there is only 1 proton and 5 neutrons. So number of neutrons is more than proton, that is right, but what is the ratio? It is 5:1. Okay, so extreme conditions are existing here in this isotope, extreme conditions, because ratio of neutron to proton is so high, and that's why this is so interesting. Okay, so how this actually A1 collaboration team conducted this experiment using Microtron particle accelerator, Mainz Microtron particle accelerator they used at Johannes Gutenberg University Mainz in Germany. And in this international team, there were researchers from Japan and China also. Okay, that means this experiment was conducted by an international team. And they conducted their experiment almost over 4 weeks at a stretch. And they observed one hydrogen-6 event per day, and they used ultra high, or better to say high resolution magnetic spectrometers to detect the scattered electron, the emitted proton and the pion, because in the nuclear reaction positive pion was produced, the neutron was produced, and an 855 mega electron volt electron beam was used to target lithium-7 to hit lithium-7 target. Okay, an 855 mega electron volt electron beam was used to hit lithium-7 target. So this way nuclear reaction occurred, and in the process there is a scattered electron, emitted neutron is there, emitted proton is there, again positive pion is there, and all these things were detected and measured by high resolution magnetic spectrometers, and the measurement was so precise. So here you can see ratio of neutron to proton is so high, and the ground state energy was measured, and it was lower than the predicted values. Predicted values means what? They used existing nuclear models to predict the values, and there was a great mismatching. Okay, that means our existing nuclear models are not fully correct. Revisions are required to our current nuclear models. That is the significance of the experiment. That's why this experiment is so interesting. Next is a new method was discovered, because electron beam was used, okay, to create hydrogen-6. That means again we can do the same thing. Again we can use electron beam to create isotopes where ratio is so high, neutron to proton ratio is so high. Again, if you can study in detail this type of isotope, okay, and you know that in neutron stars, in case of supernova explosions, such environments are there, almost such environments are there. Okay, so those things can be studied accurately if you know the properties of such isotopes. So these are what? These are the significance of this discovery. Okay, anyway, so this was all about today's topic, and this is the end of this video. If you found this video insightful, so please like, share and subscribe. Okay, this is the end of this video. Thank you for watching this.